All right, you guys, let's cover the review for Chapter 6 for Geometry AB. I'm going to work the odds through with you and go ahead and get started on number 1. All right, so we have a proportion set up right here. In order for those two things to be equal, their cross products must be equal, which means when I cross multiply, I will get an equation where x times 15 is 15x, and it should be equal to the others multiplied together. So 6 times 10 is where I get 60. So from here I'm going to divide both sides by 15, and I'm going to get x equals 4. So I'm going to write x equals 4 and go ahead and put that in my box. Number 3 is a geometric mean problem, and it wants us to calculate the geometric mean between the two numbers given and round to the nearest hundredth. The basic format of geometric mean is a over x equals x over b, where a and b are the two numbers that they give you. So when I set up this proportion between 4 and 9, I'm going to replace a with 4 and replace b with my other number, 9, and then cross multiply like we did on the last problem. So 4 times 9 is 36. X times x is going to be x squared. And to cancel out that squared, you're going to do the opposite, which would be to square root. The square root of x squared is x. The square root of 36 is 6. This one we didn't need to round, so we're just going to leave it as the whole number. Number 5 is the same thing, geometric mean between 2 and 25. So I'm going to rewrite this as 2 over x equals x over 25. And we will cross multiply. 2 times 25 is 50. X times x is x squared. So when I square root this, because it says I can round, I'm going to actually type this into my calculator, the square root of 50. So square root of 50 comes out to be 7.07. 7.07106. And if y'all remember, when you round, nearest hundredth is 2 decimal places. That means I want to change or keep that second decimal place, and I'm going to look at the number after it to see if it bumps it up or keeps it at that 7. A 1 isn't going to bring that 7 up. Remember, it has to be higher than 5 or equal to 5. So this is going to just drop those last numbers and leave that one as a 7. So our answer will be 7.07. All right, let's skip down to number 7. Number 7, we have two figures that are supposed to be similar, and we want to find the values of the variables. Well, I always do my angles first. In this problem, there aren't any angles. Actually, they do want us to find A and B. A and B are angles, and the reason why I pick angles first is because there's little work to be done in order to find them, because it's really just identify what its matching pair is and see what you can find. Angle A is in X. And since x is a last name, it needs to correspond to the last name in the first triangle. So x and c should both be the exact same value, because if polygons are similar, their angles are congruent. So angle x is congruent to angle c, and therefore I can say A, the measure of angle x, must be 62 degrees as well. Notice how I put a degree sign, because A is representing that whole angle. All right, B is in the Z spot. Z is the first name, which should match the first name in the other triangle, which is A. A is 56, so 56 and B must be equal because A and Z are congruent. So B is going to be 56 degrees. X and Y are the sides of your polygon. And whenever you're talking about the sides of a similar polygon, they're going to be proportional. So we need to write a proportion that compares the correct corresponding sides together. Let's say we want to find x first. X is side XZ. XZ is a first name, last name. segment, so it needs to match first name, last name in the other triangle, which would be AC. So that means 28 and X match each other. Then I'm going to look at Y. Y is side XY, which is a middle name, last name. So XY should match middle name, last name, which would be BC in the first triangle. So that means 16 and Y match each other. That leftover side must also match each other. And not only that, but we know both pieces of those sides, which means that's going to be my ratio that I compare in both proportions. So I'm going to choose to do big over little for my proportions, and I'm going to use that the whole problem. Big for the ratio that I have is 24. The little piece that matches is 18. So let's say we want to find X first. If I pull from the bigger triangle first, that would mean 28 has to be on top, and then X has to be on bottom because it's from the little triangle. So I'll cross multiply. That gives me 24X equals 18 times 28, which is 504. And when I divide both sides by 24, that gives me X equals 21. Sorry, y'all can't see that. There you go. So X is 21. There's no degree sign because it's representing a side. Now I want to do the same thing, set up the same proportion with 24 over 18, my basic ratio. And I'm still doing big over little, but this time we're going to compare it with Y. So it needs to be equal to, the pinks go together, so 16 and Y, whatever number comes from the bigger triangle, which would be 16, goes on top. So 16 over Y. Now we're going to cross multiply. We get 24Y equals 18 times 16, which is 288. And then I'm going to divide both sides by 24 to get Y equals 12. And then we're done. All right, looking at number 9. Number 9 is asking us to find or to determine whether the triangles are similar. And if so, state the reason. So remember, our 3 reasons we can have are angle-angle similarity, side-angle side similarity, and side-side side similarity. Right now, we have one angle that's congruent. So we do have one set of angles, which means we're definitely not using side-side-side for this one. But just because the sides are labeled doesn't mean that they're proportional. And when you have similar polygons or similar triangles, you need their sides to have the same ratio. So when I compare these, I'm going to compare 8 to 12, and let's do left over right. So left over right would be 12 over 8, and left over right with the other 2 sides would be 9 over 6. We want to check to see what these reduce to see if they're going to be the same. 12 and 8 are both divisible by 4. So if I divide 12 by 4, that gives me 3. 8 divided by 4 gives me 2. And I want to see, is this equal to the reduced 9/6? 9 and 6 are both divisible by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. When they're the same like that, it means your sides are proportional. So right now we have side, angle, and side compared to side, angle, side. So my answer would be yes, these are definitely similar, and it's because of the side, angle, side similarity theorem. Remember that angle is the one touching both of the S's in the name, so it needs to touch both of your proportional sides in your picture. All right, number 11. Number 11 right now has one set of congruent angles, and when I look, my corresponding sides are 6 and 9 and 8 and 12. Even if we check to see that those both reduce to 2/3, the location of them is not fitting with angle-angle. It's not fitting with side-side-side because we're missing CB and FE. And the only other option to choose from is side, angle, side. But remember, in your name, side, angle, side, the angle needs to be between and touching both of the proportional sides, which in our picture, your angle is only touching one side that is proportional. So right now, we don't have enough information to say these are similar, and it's because there's not enough info. All right, number 13. Number 13, we have three sides set with each other, and we need to look to see if they are proportional, because when we check sides are proportional, we need to make sure that we're comparing the right sides. When you look at this, our triangle right here is essentially flipped. So when I compare these sides together, I don't know necessarily which order they go in. So right now I'm thinking, okay, well, we've got this triangle where the base is 14 and it's been rotated. So we've got this side is 15 and this is 12. This is the upright version of this. So I'm going to compare 15 the left side to 24. And let's see, we'll write 15 over 24 and see if it's equal to, we did little triangle over big, so we're going to do little over big for 14 and 21. And we're going to compare that to little over big, 12 over 18. (12 divided by 18 is the decimal 0.6 repeating. We need to see if that's equal to 15 over 24, which is 0.625, and check 14 over 21. 14 over 21 is 0.6 repeating. Two of the sides are proportional, but this one has a different value for its ratio, which means they're not all proportional. So I would say no, because my sides are not proportional. All right, we'll go ahead and look at 15 as well. Number 15, we have two triangles. One of the angle pairs is congruent already. One thing I noticed is this is a bow tie problem. Remember, bow tie problems have congruent vertical angles. And right now, that's all I needed to add in order to say that we have two angles congruent to two angles in the other triangle. So this would be a yes by angle-angle similarity. All right, you guys, we're going to end this video and then catch up with the next one.